Okay, this is part 3 of the little video series that's kind of going through everything that we've gone through up through this chapter. You do have a test on Wednesday. So first we want to refocus in on what a stock system is used for, and that's whenever you have a transition metal. Okay, and with your transition metals, that's everybody in the D sublevel all the way to your metalloids line. With these guys, you have to use Roman numerals to indicate their charge. Okay, a polyatomic is just going to be something covalently bonded that has a charge. So for example, we have a whole list inside your periodic table. Nitrate would be something like NO3, but so these things are covalently bonded, but it has a -1 charge, therefore it can mix in with a metal. Okay, so for our first example, we're going to start with copper and nitrate. Okay, so first you would recognize, okay, we have a metal, so that means it's ionic. Then we would look at our metal, and that guy is found in the center of your periodic table, so that means it's transition metal. So that tells you that we got to do stock system method. So if you did not watch video 2, you need to watch that one first. Otherwise, I'm just going to keep going here. So because we have transition metal, we got to focus in on our anion. So our anion for this one is nitrate. If you look at your list, nitrate has a little negative there. Okay, what that means is that this is nitrate is NO3, meaning you don't mess with anything inside the parentheses, but it has a -1 overall charge. So we're going to go ahead and put our little -1 over here. Okay, and we want to know, what is that total negative charge? Well, there's only one nitrate here. Okay, if you're having a hard time seeing that, what I like to do is I just kind of go over it and I'm like, there's the blob. There's only one blob. If I had 2 blobs, then it would have looked like this. It would have been a blob with a little 2 on the outside. Okay, so make sure you're not making the mistake of using the subscripts on the inside to indicate that. So this, you only have one nitrate. One nitrate. So we have -1 times 1 means we have a -1 charge overall. Well, these have to balance out to equal 0, so that would mean that this would have to be a +1. We are going to divide it by the number of coppers that we have, so we only have 1, so that gives it a +1 charge. So our name would then be copper 1 nitrate. Okay. All right, for our next example, we're going to go ahead and do, we're going to do we're going to do Cu, and then I'm going to use OH. Okay, so if you look this one up, this is hydroxide. Okay, so hydroxide, and he has a -1 charge. Okay, so looking at that, I know that this has a -1 charge. I'm going to put my parentheses so that I know it's a polyatomic. Again, I'm going to multiply it by the number that I have, which is only 1. So there's a -1 charge overall. I have to balance out to equal the number 0. So this has to be a +1. Since there's only 1, that would again be a copper 1 hydroxide. Now, what I meant to do for this example was actually CuOH with a little 2. Okay, now how does that change this up? Let's go ahead and look at that. Okay, now what we're looking at is I still have that -1 charge. Okay, that -1, now I'm going to multiply it by 2, so I have a -2 overall. I need it to equal 0. So that missing number has to be a +2. I'm going to divide it by the number that I have, which is only 1. So each one is going to be a +2 charge. Okay, so we would call this copper 2 hydroxide. and finally, we're going to go ahead and use this example. So I have SN2 CO3 little 5. Okay? So looking at this example, this doesn't look like a transition metal right away, but just remember your definition for transition metal means that it's basically not group 1 or 2. Okay? So this guy is definitely not in group 1 or 2. He's underneath the metalloids line. So we're going to go ahead and use the transition metal idea here. And we're going to analyze our CO3 polyatomic. So if you go look that up, that is actually carbonate. And it looks like this, CO3, and it has a 2 minus here. Okay, so that means that we have, this is our blob. Sorry. Here's our actual molecule here, and then we have a -2 charge overall. Okay, so that's where this 2 is coming from. All right, so we have that -2. I'm going to multiply it by the number that I have, which is 5. Has nothing to do with this. Don't worry about that subscript. But 2 times 5, we're going to have a -10 overall. All of this has to equal the number 0, so that means that this has to be a +10. I'm going to divide it by the number that I have, 2, the number of metals that I have, and that will give me a +5 charge. So this is actually tin 5 carbonate.